Hi, I'm Brett Barbero and I'm recording an instructional video for the Flytracker program. The Flytracker program is a program that I wrote in the Marsh lab, the lab of Dr. J. Lawrence Marsh at the University of California, Irvine in approximately 2012. The purpose of the Flytracker program is to measure the geotaxis of flies, and that is the tendency of flies in a vial to climb up the tube. You can see here they're running around. If you tap them down to the bottom, then they all start climbing up. Now, all flies exhibit geotaxis, but in our lab we're studying neurodegenerative disorders, and in particular Huntington's disease. So animals that are affected by the Huntington's disease phenotype will climb more slowly than animals that are not affected. And the way that we measure this is by using this assay. So what we have here are 6 different genotypes of fly, and we're going to compare how well they climb. And the way that we're going to do that is by setting them into these empty tubes and then performing the geotaxis assay on them all together and videotaping it. And then that video will be analyzed by the Flytracker program to produce statistically significant results about the climbing abilities of these flies. So fundamental pieces of equipment that are necessary. The assay has been designed so that it makes use of common lab equipment. So this is a common fly rack. These are common fly vials. And this is a commercially available camera. The program has been designed to work with pretty much any sort of video input, so any kind of camera would do. This is another rack that was constructed out of a Bloomington Drosophila box, and you can put the flies in there and measure them as well. Alright, so we're going to transfer these 6 vials of flies into these empty vials. These are plain empty plastic vials, but I do want to make a note about the cap. You see here, this is one of the synthetic plugs that has flat bottom, and it's sort of made out of foam. These are better than cotton because of the flat bottom, and that will become, the reason for that will become apparent pretty soon. Flies do not need to be anesthetized, so it's a much better way of comparing flies than if you had to anesthetize them. Now, I would usually start with equal numbers of flies, and in this case, these vials were not prepared specifically for this video, so the numbers of flies are going to be slightly different. Another thing that you really want to be careful with when doing these experiments is glare, because if there is a reflection in the tubes when you're doing this experiment, that reflection can throw off the analysis. So I try to have the room dark and the light board light, and this is the only source of light that I use when I'm doing this experiment. This is a standard, I don't know, Casio XLM camera. It doesn't really matter. And I'm turning it on, and it's powering up, and you can see here the vials. And it's got an autofocus feature on it, which is very nice. And I'm going to zoom in a little bit here so that the vials are nicely framed in the window. Now, one very important thing is this rack. And actually, not necessarily this rack, but this rack that we're actually doing the assay with. This rack has to be at the appropriate height so that that crossbar is as minimal as possible. And if you see, if I lift it up, then you get that crossbar looking like, you know, like a waffle iron in there, and that takes up space in your image, which is going to have negative effects on your analysis. That's interesting. Alright, so yeah, you see there, this line down there. I'm going to try to get rid of that. I'm just pull a sheet of paper out and just kind of hang it over. Alright, now that looks pretty good. So another important thing, you see the plugs along the top should all be at the same level. So the bottoms are at the same level, because the flies are going to be racing, and we want to make sure they all have the same finish line. And I guess the most important thing is that they're the same level in this image. And that should be good enough. Alright, good. Alright, so the first thing we're going to do is have the original stack, the original vials here, and I'm going to take a video. So I start the camera, let it focus on the vials, and now the recording has begun. I'm going to turn off the rest of the lights here, and I'm going to perform my assay. So my flies, they're in the correct order, and alright, I'm just going to do it. Okay, here we go. Okay, let them fly up. Usually 1 or 2 or 3 seconds, not one. Usually 5 seconds is a good amount to let them fly. 3, 4, 5. I gotta say, they're actually not looking like they're going to be showing any really dramatic differences. So the more times I do this, the better the results are going to be. For some reason, this cork here at the top seems to be like sliding down. So I'm going to move that. That's a little better. So I would often try to do this about 20 times or something. And in the analysis part, we will take all of those different runs and do statistics on them so that we would have some pretty reasonable results. I can tell you right now, I don't think we're going to see anything interesting here. So I guess the hypothesis is that the miles to go flies would climb more slowly, and we'll see. I don't know how many times I'm doing this. You know, what I actually do is usually look at the number of minutes that have passed, and I do it for 3 minutes or something. Doesn't really matter though. So one thing that's important though, all right, is that after I tap them down, I have to remove my hands and let go completely and let the flies just sit there, because the program needs to have a stable image in order to do the proper calculations. Every time I put my hands into the picture, the program will detect that and use that to segment the video into individual runs of the flies. So yeah, so you let the flies climb for up to like 3 or 4 seconds, because once they start getting to the top, then they bunch up there, and the results are no longer very interesting. So this has been going for 5 minutes, 20 seconds. I think it's probably pretty good. So I'm going to shut it down. And that's it. That's the end of the assay. Okay, so the next thing is, what do we do with this information? Well, this camera has got a SD card in it. And I'm going to pull that out. And we will insert this into my computer. And so I'm